Hello. Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and Simi Richard here. Okay, we are looking at application of impulse. Okay, it says that a bullet of mass 20 grams strikes a target at velocity of 300 meters per second and exit the target at 200 meters per second in the same direction. The bullet takes that time 0.0002 seconds to pass through the target. And the question comes, calculate the change in momentum of the bullet. Okay. So what do we do here? This is what you have to know. We are looking for change in momentum given by this formula. Now the onus is on us to find out whether we have the data, the information needed for that. Let us start. What do we have in the information? We have the mass, which is 20 grams. And that was not a SI unit, so we change it to kilograms. And what do you get here? So we get 0.02 kilograms. Okay. What else do we know? We know the initial velocity, which is 300 meters per second. What else do we know? We know the final velocity, which is 200 meters per second. Okay. And we know the time taken for the bullet to go through the target, which is 0.0002 seconds. Okay, with this information, then you go back to our formula. Do you have enough information to substitute and get the answer? The answer is yes. We must not forget that our unknown here is change in momentum. So what are you going to say? We are going to say that change in momentum is equal to mass, which is that, times the final velocity, which is 200 meters per second, minus that mass, which is 0.02, times the initial velocity, which is 300. Okay, let's see what we get. And if from there we get our answer as -2. Okay, let's -2 is change in momentum, kilogram meters per second. And what does negative mean? Negative implies direction. Direction is opposite to the initial direction of movement of the bullet. So we can say here as 2.00 kilogram meters per second opposite to the initial direction. Yeah, then comes this question. It says, calculate the net force on the bullet. Okay, how do you approach this one? Here, the best approach is to have our equation. F net is equal to delta P over delta T. Okay. The question is looking for net force. So we have it here as our unknown. What else do we know? previously we calculated change in momentum and we found it to be negative 2 kilogram meters per second. And we have the time. Our time is 0.0002 seconds. Now, with this information, what do? We substitute. You say F net is equal to change in momentum, which is negative 2, and divided by time, which is 0.0002. And what you get out of that is going to be our net force. So it happens to be negative 10,000 newtons. Okay. And what does the negative imply? Like in our change in momentum, negative implies opposite direction. So the net force on the bullet is in opposite direction to the direction which is taken by the bullet. So we can rewrite it and say answer is 10,000 Newton opposite. Okay, then comes the next question. It says, what is the impulse the bullet exerts on the target? Explain your answer. Okay, you have to remember to do this. This is what you have to know. You have to know that we have this expression known, the impulse momentum theory. What does it say? It says that impulse is equal to product of net force and time, or change in momentum. And we know the change in momentum of the bullet. So delta P of the bullet is known and is negative 2 kilogram meters per second. Okay, I want you to know that in accordance to physics principle, which we get from Newton's third law, the impulse on the bullet is the same as the impulse on the target. Why? Because both of them are experiencing the same change in momentum. So what is going to be our answer? Our answer is going to be 2 kilogram meters per second. And it is positive. Let us put here to emphasize it. Positive because change in momentum of the bullet was negative. Remember, they have the same change in momentum, but opposite in direction. So, positive means what? Positive means in the direction of the bullet. So change in momentum of the target is plus 2 kilograms. It is in the direction of the bullet. Explanation, we say in accordance to Newton's third law, the change in momentum of the bullet is equal to change in momentum of the target. And with that, we'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. See you next time. Don't forget to subscribe. Don't forget to like. Don't forget to comment. We are simply the best.